So, rocks. The geology of Minnesota is quite a long and interesting one. There are many factors and events to take into account. But luckily for me, I'm taking a class about exactly that. And before we get into actual content about Minnesota specifically, I need to recap some general geology. There are three main types of rocks: igneous, sedimentary, and metamorphic. Igneous rocks are formed from the cooling of magma and lava and are classified differently depending on where they formed. If a rock formed from magma underground, it is called an intrusive igneous rock. If a rock formed from lava on the surface, it is called an extrusive rock. The main types of intrusive rocks in Minnesota are gabbro, anorthosite, and granite. The main types of extrusive igneous rocks found in Minnesota are basalt and rhyolite. There are three types of sedimentary rocks: clastic, chemical, and organic. Clastic sedimentary rocks are what most people think of when they hear the words sedimentary rocks. Clastic sedimentary rocks are formed by the erosion, deposition, and compaction of sediments. Chemical sedimentary rocks are formed from the precipitation of particles, not to be confused with the other precipitation, which is rain, snow, or hail falling to the ground. To precipitate means to become a solid, and we'll get into an example of that later. Last but not least, we have organic sedimentary rocks, which are formed from the remains of dead organisms. For example, coal, although there really isn't any of it in Minnesota. Examples of clastic sedimentary rocks in Minnesota are sandstone and shale. Examples of chemical sedimentary rocks are limestone and dolostone. The last type of rock is metamorphic rocks. Metamorphic rocks are formed when other types of rocks go under intense heat and/or pressure. Two types of metamorphism are contact metamorphism and regional metamorphism. Contact metamorphism is when a rock is metamorphosed through intense heat. Regional metamorphism is when a rock is metamorphosed through intense pressure. The main types of metamorphic rocks in Minnesota are gneiss, slate, and greenstone. Now you might be wondering how there's metamorphic rocks in Minnesota if there's no fault lines or volcanoes to cause them to form. Well, we'll get back to that. Oh great, we're done talking about different types of rocks. What are these rocks even used for? I mean, we have so many different kinds, so they gotta be good for something, right? Igneous rocks such as granite and gabbro are used a lot for construction due to their strength. They're mainly used in buildings for both interior and exterior, roads, foundations, monuments, and concrete. Limestone, which is a sedimentary rock, is also used to make concrete, and it also can be used for asphalt for roads. Shale, which is also a sedimentary rock, is used to make brick and tiles. Gneiss, which is a metamorphic rock, is also used to make buildings and monuments. The rocks in Minnesota are many different ages. Some of them are 1.8 billion years old, some are 1.1 billion years old, and some are only 450 million years old. Now, it is time to recap the entire history of Minnesota, North America, and the Earth. 4.6 billion years ago, the Earth formed. Yippee! Then a Mars-sized object hits the Earth, and now we have a moon. Yippee! Again. Eventually the Earth cools down from the chaos of its formation and becomes a water planet. 3.8 billion years ago, the first life forms. But it won't be multicellular for a couple billion years. Our first stop in Minnesota's history is 1.8 billion years ago. At the time, the location that would eventually become Minnesota was the bottom of the ocean. The mountains of the ancient Earth contained lots of iron, which were slowly eroded away over time. The iron slipped into the oceans, reacted with oxygen in the water produced by photosynthetic cyanobacteria to make iron oxide. The iron oxide precipitated and fell to the ocean floor, where it was buried by other sediments and compressed to form iron ore. That's right, iron ore is a sedimentary rock. At roughly the same time, sediments elsewhere compressed to form shale, a different sedimentary rock. This is important for later, remember this. 700 million years years later, that's 1.1 billion years ago in total, a drastic event began. Minnesota was part of a supercontinent named Rodinia and laid very close to the equator. A magma plume from deep within the mantle rose up and formed a rift in the middle of the supercontinent, and it began to split it apart. Massive volumes of lava poured out of the rift, and a huge basin was formed. Remember this for later too. Much farther east, a mountain range called the Grenville Mountains began forming. Luckily, the formation of these mountains caused the rift to fail, and the continent did not split apart. The lava from the rift cooled and formed the very igneous rocks found in northeastern Minnesota. But the rift had one last trick up its sleeve. The intense heat released by the rift caused the shale, remember that, to metamorphose into slate, tilting it to a unique 45-degree angle in the process. This rare slate can be seen nowadays at J. Cook State Park. Not sponsored. Skip ahead about half a billion years and things have changed a lot. Life is multicellular and thriving in the Ordovician seas 450 million years ago. The area that will eventually become southeastern Minnesota is a beautiful coral reef and a shallow tropical sea. The rising and falling of the seas over a couple hundred million years caused lots of buildup of sedimentary rocks such as sandstone, limestone, and dolostone. When creatures in this time period died, their bodies fell to the seafloor and the soft parts rotted away, leaving the hard parts behind. Over time, these body parts, mainly shells, got buried under the sediments and rock and were fossilized. The last stop on our geologic journey through time is the latest ice age, which lasted from 2.4 million years ago to 10,000 years ago. During this ice age, massive ice sheets formed, some up to 3 miles thick. As the ice sheets plowed across the continent, they acted like bulldozers, flattening land, carving out the Great Lakes, including the basin left over from the mid-continent rift, transferring agates farther south, more on them later, and leaving scratches in rocks called striations. When the glaciers began to recede, sometimes a large chunk of ice would break off and form a lake known as a kettle lake. Southeast Minnesota is not just a land of 10,000 limestone deposits, it is also the land of 10,000 random holes in the ground. This is due to the karst topography of the area. Because the land is built on soft sedimentary limestone, acidic rain can wear away at the rock, creating sinkholes and cave systems. This leads into its own whole section of content with landforms like disappearing streams and all the speleothems that can be found in the caves down south. Things are a little different up north. Due to the abundance of igneous rock, there are no sinkholes or caves. What it does have, however, is iron, baby! Oh yeah, we get to talk about iron now. Can you tell I'm tired? Because of all this 1.8 billion year old iron ore, people set up a crap ton of mines there. There are 3 iron ranges in Minnesota, but only one of them is active nowadays. Companies pay a ton of money to get permits to mine on the land, and they set up giant open pit mines to find that rich iron ore. They turn it around and sell for profit. Because of this, Minnesota is the #1 iron producer in the country. These boring mines are not the only interesting landforms in the Northeast. In some places, iron ore is combined with other rocks and minerals to create a really interesting feature called the Banded Iron Formation, and scientists today still argue about how it was created. Also, because of that rift incident over a little over a billion years ago, we get a ton of basalt and rhyolite and other crap. But inside some of these rocks is something special. When lava cools and hardens, it sometimes has carbon dioxide bubbles inside of it. These bubbles are known as vesicles and get trapped inside the rock. Over time, water and minerals such as quartz and silica can fill up the vesicles and form these beautiful gemstones known as agates, which are, fun fact, the state gemstone. There's one more important landform in northeast Minnesota, and it's kinda hard to miss. That's because it's the massive Great Lake that is Lake Superior. Lake Superior has quite a long and interesting backstory of its own, but I don't want to get sidetracked. In short, the rift event created a depression in the ground called a basin. Over the next billion years or so, it got filled up by sediments. When the glaciers showed up over 2 million years ago, they excavated the basin when they carved the other Great Lakes. Then, they melted, filling up the basin. So, you might be thinking, that is way too much water to fit in Monte Lake Superior, and you'd be right. When the lake first in, the water level was multiple hundreds of feet higher than it is nowadays. The lake back then was known as Glacial Lake Duluth, and changed the shoreline, created many interesting cliffs and waterfalls, such as the Triple Falls at Gooseberry State Park. Okay, cool. We've got 2 completely separate areas of Minnesota, each with their own dramatic geologic histories. But are they really that different? Mostly. They do have some similarities. Both regions have sedimentary rocks. However, only the northeast has metamorphic and igneous rocks. Both regions have a sea or ocean involved in their formation, but only the southeast has karst topography and caves and sinkholes. Both regions are somewhat affected by glaciers, and both regions have agates, I think. Now, I ask myself the question, what the hell have I actually learned in the past month-ish? Well, I've learned about limestone and karst topography. I've learned about caves and sinkholes and how they form. I've learned about all the cute little speleothem you can find in caves, stalactites, stalagmites, flowstone, cave bacon, and more. I've learned about the ancient seas that once covered the earth and the cephalopods that lived there. I've learned the Great Superior was not, in fact, carved solely by the glaciers like I've been led to believe my whole life. I've learned why Minnesota is the #1 iron producer in the country, why there's so much iron there, every important step, how to mine the iron, from blasting it out of the ground to crushing it to making it into pellets, shipping it across the lakes to be made into steel. I have learned about the chaos created by the mid-continent rift, how it created the unique tilted slate and massive lava flows. I've learned how agates form and how to find them, and also the fact that they exist because I had never heard of them before this class. And last, but most certainly not least, I have learned to care for my classmates in my home state just a little bit more each and every day.